In this case, we're using a Bosch relay in our example, and terminal 30 is usually used for voltage or current input. But again, this changes from manufacturer to manufacturer, but it is always important to know and to simply understand that you actually need a voltage or a current source to actually trigger whatever load it is that you're trying to turn on. In this particular case, this relay is actually triggered by the actual ECM, which provides a positive volt or a current source on the positive side, completing the circuit across the coil to the negative side. And this terminal should actually, as we did before, should actually be checked for a voltage source. Again, not all relays are triggered by computers, and a lot of them are triggered by switches and so on and so forth, but you should always make sure that you have a voltage or a current source going into the relay. And again, the final step in relay testing is to simply make sure that no voltage is being dropped across its internal contacts. In other words, the relay acts as a straight-through conductor, and very little voltage, usually at a maximum within a range of 20 to 30 millivolts, if that. For the most part, they're very, very close to zero. Relays could be either positively triggered or negatively triggered. If it is a positively triggered relay, like in a upper example here, the actual switch or ECM, whatever is triggering the relay, actually provides a positive voltage. The other side of the coil is going to be connected to ground, and this is how you determine how the relay is actually triggered, and this is important whenever trying to follow the current path. In the bottom example, we see how a negatively triggered relay, we actually, the ECM or the switch actually provides the negative, and we see how the other side of the coil is directly connected to the voltage source, and the current flows in a different pattern. So whoever provides the actual pulse, whether negative or positive, that's what's going to determine whether the relay is negatively triggered or positively triggered. Again, you can simply go and study your diagram and determine whether the actual coil is directly tied to ground. If it is directly tied to ground, then you know that the actual relay coil is going to be triggered positively. If it is directly tied to positive or voltage source, then it is going to be negatively triggered. Again, this is all very important, since the actual triggering of the relay is going to determine the actual flow of current. Here we see how we can actually test the actual coil windings of a relay by actually measuring the current flow rather than the voltage across the coil. Relays drop very little current within the range of 3 to 500 milliamps. So it depends on the actual relay that you're testing. If it's a big enough relay, you could drop even higher than that. But as a rule, relay coils drop very little current. The other way to actually test the second part of the relay, which are the contacts, is by measuring the current flow across the actual load or the output of the relay. Remember that all you have to do is look at the fuse to which this relay is connected to, and fuses are always rated at twice the current carrying capacity of a circuit. So if you are trying to determine if the say for example a motor that is connected to a relay, in this actual example, you're trying to determine if this motor is drawing the appropriate amount of amperage or current, all you have to do is look at the actual fuse to which this circuit is connected to and divide it in half. If it is a 30 amp fuse, you know that the nominal current carrying capacity of this circuit is going to be 15 amps. So again, always divide the fuse to which the circuit is connected to in half, and that is the nominal current. It doesn't have to be exact, but it will hover around this half figure of the actual fuse.